All right, section 3, special products of polynomials. Okay, so one of the important things to understand here for the special products part, kind of the key operative word here is that we're dealing with products. Okay, that means that we're still dealing with multiplication, just like we were in section 2. Okay, so, and we're still multiplying polynomials. Okay, so those things are pretty much an extension of section 2, right? Products or multiplication of polynomials. The fact that we're dealing with special case scenarios, I'll just kind of throw this disclaimer in early on. The textbook really tries to make a push for us to learn these extra structures of what, like, they call them shortcuts. Okay, they're not that short, and in fact, they don't save you any time at all. So I'm really just going to teach kind of an extension of section 2, the distribution and collection of like terms techniques. But one thing I have included in the solutions and in these notes for the sake of our solutions and stuff, one thing I've included is I've included how to solve using these shortcuts. So I'll just briefly describe them as we're going through the notes, but for the most part, as long as you're comfortable with the stuff that we were doing yesterday in section 2, with distribution and collection of like terms, this stuff will be more of the same. Okay, so let's just jump right in. For the record, these two methods I'm going to talk about, particularly the ones that the methods that the textbook says to use for the structures, aren't particularly time-saving, but we will talk about one in a little bit that will definitely save you some time. So there is one technique in here that will definitely be worth memorizing. Okay, so without further ado, squares of a binomial. This is a very fancy way of saying I'm going to have some parentheses, a binomial, two-term polynomial, and it's going to be squared. Okay, you're going to see either a binomial with addition, or you're going to see a binomial with subtraction. Okay, you're going to get several of these problems in this section assignment, and it's basically going to be phrased the same exact way all the ones were phrased in section 2, where it's going to say find the product, which is another way of saying multiply the given polynomials. Okay, and so I'm just going to briefly talk about the two different techniques that the textbook points out. They say, like, okay, A and B can be anything, right? X and 5 would be an example of like an A and B right here. A and B just represent that this is a binomial. Okay, whatever term A is and whatever term B is. Okay, so when I square that binomial, when it's being added together, I'm going to get this result. Okay, A squared plus 2 times A times B plus B squared. What does that mean? Okay, that means whatever my first term is, however complex that monomial is, I'm going to take that and square it. That's going to be the result in my answer. That will be my first result. For my middle term in this, I'm going to take both of my binomial terms, whatever they may be. I'm going to multiply them together. Okay, so like in this example, that's x and 5. I would take x and 5 and multiply them together. But whatever these two terms, I'm going to multiply them together, and then I'm going to double that result. That will be my middle term. And finally, for the last term here, whatever my last term was in my parentheses, in my binomial, I'm just going to square that value, and that will be my result. So for instance, in this example, x plus 5 quantity squared, my first term was x. When I square that first term, I get x squared. My two terms were x and 5. So if I multiply those two together, I'm going to get 5x, right? And if I double that, double the 5x, I get 10x. And then for my last term here, the 5, if I square that term, I get 25. Okay, that's the structure they're talking about building into. All right, now what happens if I have subtraction in that binomial? The only thing that really changes here is the same exact format as above, except now this sign will be a minus sign. Okay, and so I take my first term and square it. So if it's x minus 5 quantity squared, x squared is x squared. Okay, yep, thank you, Adriana. Okay, x squared is x squared, right? And now my two terms are x and 5, so I multiply those two together. I get 5x, double it, that will be my middle term. So 10x, Just remember that in this case, because there's a minus there, there'll be a minus here. Okay. And finally, my last term squared is 25. All right. So these are the techniques that the textbook teaches you to do for these special products, namely squares of a binomial, whether it's plus or minus. These are the structures it teaches you to use. Okay. If you're comfortable with that, if you're willing to kind of explore that and try it out, by all means, go for it. What I will be typically doing is just continuing on with distribution methods. So let me just break this down really briefly. So for instance, here for this first example, when they gave us x plus 5 squared, okay, I can actually rewrite that as x plus 5 times x plus 5. Because squared just tells me how many times it's multiplied by itself. I'm just multiplying it by itself twice. Why did that matter? Because this is the exact same thing that we did in section 2. And if you're comfortable with the techniques we did in section 2, by all means, just continue doing it for these kinds of problems. Take your first object, x in this case, multiply it throughout the next parentheses. X times x, x squared. X times 5, 5x. I'm done with that first object, move on. Positive 5 times x, positive 5x. Positive 5 times positive 5, positive 25. Okay, there's my distribution. Collect my like terms. There's my middle term. You'll notice that both of these results, didn't matter the technique I used, I got the same answer. Okay, which is why they have this structure to begin with, because it's just another way to do it. Your assignment will not distinguish between which one is the correct method and which one is not. On my test, I will not distinguish which way is a correct method or not. So if you are more comfortable with this section 2 technique of just multiplying the polynomials, stick with this. You will get correct answers. If you're comfortable learning this new technique about the structure, by all means, go for it. It does work. But it's just a new technique to learn. And I know that for a lot of us, that tends to be just another chore. Okay. Same thing down here. If I got x minus 5 quantity squared, I could rewrite that as x minus 5 times x minus 5. And just like before, I do my distribution collection of like terms to get my result. Okay, so let's go ahead and do an example. I show both techniques in the solutions, by the way. So if you're curious about either, they are in the solutions, which are uploaded onto Google Classroom. But let's go ahead and reference those right now. Again, on Google Classroom. All right, so here's that first example. I have 5x minus 2y, and then I square that binomial, and I'm asked to find the product. Okay, so really the setup is no different than the stuff that we got in section 2. I'm asked to find a product. I'm given a binomial, and I can rewrite that as 5x minus 2y times 5x minus 2y. Here is the distribution method. I'm going to explain my way through that in just a moment. But if you are interested in this other technique that the textbook identifies, it does work. But as you can see, it's kind of the same amount of work as the distribution method. So there's no real time save there. So it's not like you're gaining an advantage. Okay, so I'll talk through the distribution method, mostly just to give us a review from section 2. Again, anytime I have polynomials multiplied by each other, I'm just multiplying and distributing and then collecting like terms. So I take my first object, 5x, multiply by 5x. That gives me 25x squared. That same 5x multiplied throughout this parentheses, 5x times negative 2y. This one tends to trick some students because there are more than one variable here. But 5x times negative 2y, my suggestion, deal with the numbers first. 5 times the negative 2 gives me negative 10. And then the x and the y are two different variables, so they don't combine in any way. So it's just negative 10xy. That's okay. That will happen. On purpose, I made this problem a little more complicated, a little more dense than some of the easy ones we just did before, because if you can handle this one, you'll be able to handle any of them. Okay, so now I'm done with that 5x distribution. So I move over. So now I got negative 2y that I've got to multiply throughout this parentheses. So negative 2y times 5x gives me negative 10xy again. And some students tend to get confused because they're like, wait, shouldn't that be 10yx instead? Because the y came first. It actually doesn't matter, the order in multiplication. Because think of it this way. Negative 2 times 5, 5 times negative 2. Either way, I get negative 10. So it actually did not matter the order I multiplied in. Just as a point of reference, like what typically big ideas will look for, what I typically do, and what most mathematicians do when I have multiple variables like this, just put them in alphabetical order. Okay, and by doing it in alphabetical order, if you had it as xy and then yx, it may be more difficult to identify that they're actually common terms that can combine. Because whether it's xy or yx, they still can combine because it's the same variables. And again, the order doesn't matter in multiplication. So anyway, negative 2y times positive 5x is a negative 10xy or negative 10yx. It's the same thing. Okay, and then negative 2y times a negative 2y gives me positive 4y squared. There's my distribution. Collect my like terms in the middle. That gives me negative 20xy. There's my final simplified polynomial in descending order. Okay, and again, I give you the technique for the structure right here. First term squared would be 5x quantity squared. To double the two values multiplied together, give me negative 20xy, and then the last term squared gives me positive 4y squared. Okay, either way is acceptable. You get to pick and choose your journey. All right, let's do one more technique from this section. All right, so as promised, this second technique that we're going to use right here, it's called sum and difference. This one will be a time saver. This one will be worth learning, okay? Not that this other stuff isn't worth learning up top, but it's just that these other techniques, these other structures to build into, it's more of just a different way to do it. There's no real time save from doing one method from the other. But this one, there will definitely be a time save. Okay, this one is definitely a shortcut. Okay, so make sure you pay attention to this one. Okay, this is called a sum and a difference. And these will be pretty distinguishable from the other techniques we learned up here, because in these ones we had some binomial squared, right? Squares of a binomial, right? So I'm going to have some parentheses squared, or it would look also like this, where I have the same parentheses multiplied by the same parentheses, which can be expressed with a squared. Okay, so it'll look like one of those two ways. Whereas this one, it can only be written one way because it can't be written with an exponent. It's two different binomials. Okay, so this is called a sum and a difference for this reason. I'm going to have the same two objects in each parentheses. They'll both be my binomials again. So I'll have the same two objects, a and b, whatever a and b are, whether it's as simple as x and 5 or as complicated as 3x and y. It doesn't matter. But I'll have the same two objects in each parentheses. And the reason we call it a sum and difference is because of the signs in the middle. One will be addition, one will be subtraction. And it actually doesn't matter which one is which, because again, the order of multiplication does not matter. So it could have been minus and then plus, or in this case, like plus and then minus. It doesn't matter, okay? But I'm going to have a sum and a difference being multiplied by each other, okay? And so in this case, I give this example of x plus 5 times x minus 5. And again, they'll be pretty distinguishable because unlike these ones, I'm going to have two different binomials. They'll have the same objects, but I'm going to have a plus and a minus. So here's the shortcut. And instead of having a trinomial result, like we had in each of the other cases, I'm going to have a binomial result. It's shorter, okay? And I'll explain why in just a minute, but I'm going to end up with this shortcut. If I see the sum and difference multiplication that I'm asked to find the product of, like both of these examples, okay? If I'm given that, I can immediately jump to a result of what's called a difference of squares. This difference of squares we're actually going to revisit in a future section in this unit when we're doing the inverse of multiplication and distribution, which is factoring. But we'll cover that in a couple of sections further from now. But difference of squares will pop up again. So this is a significant thing to understand here. Okay, so sum and difference, if I see this scenario, this is going to be my result. Whatever my first term is, and it'll be the same first term in both parentheses, I'm going to square that value, whatever that value may be. Then I'm going to subtract, that's why it's called a difference of squares. I'm going to subtract whatever the second value is. Again, it will be a shared value, but I'm going to square that one. So I'm going to have a difference or a subtraction of the two squares. So for example, in this case, x plus 5 times x minus 5. The shortcut tells me, all right, just take my first object, x, square it. There's x squared. Subtract my second value squared. My second value is 5. Okay, square the 5, 25. There's my answer, I'm done. This one is a lot shorter than these other techniques that we learned up at the top. Just to kind of set our minds at ease, if I did do the long method of distribution and collection of like terms, which you can always do, all right? So even if this is something that you don't want to commit to memory and learn a new technique, you still can use our section 2 technique of distribution and collection of like terms and get the same result. So had I done that, I would have had x and then multiply it throughout this next parentheses. X times x gives me x squared. X times negative 5 gives me negative 5x. Done with the x, move on to the positive 5. Positive 5 times x gives me positive 5x. Positive 5 times negative 5 gives me negative 25. Okay, that would be my distribution. But when I collect like terms, the reason why I can build into this structure, the reason why it's only 2 terms, is because when I ultimately get to the collection of like terms in these guys, you'll notice that the 2 middle terms here cancel out. I had a negative and a positive. That's what's going to happen when I have the plus and minus version of this, okay? And so once the negative 5x and the 5x cancel, I get right back to my original result, the x squared minus 25. All right, so let's do one example just to see this at work. You'll see that this technique here is going to be a really fast way to solve these. On purpose, I made it a little more complex than the simple x plus 5, x minus 5. Let's work through this example, and this will be how we finish section 3. Okay, so here's our 3x plus y times 3x minus y. There's our sum and difference combination. Again, it didn't matter if this was a minus and that was a plus. As long as I have the opposite signs, then I can apply this shortcut. Okay, so I'm not really going to go into depth in it, but here's the distribution and collection of like terms method that we've learned in section 2. Again, there's no real difference of technique there, so you can follow that if that's what you would like. But here is the shortcut. So as soon as I see I have a sum and difference, I know I'm going to get a difference of squares result, a squared minus b squared. So all I have to do is identify my first term. Well, my first term here is 3x, positive 3x. So that 3x is what I'm going to square. Now be careful here. A common mistake, students will see like, oh, 3x squared, my answer is going to be 3x squared. Okay, that tends to be a common gut check reaction. But if I'm squaring all of 3x, technically that means I'm saying 3x times 3x, which would actually give me 9x squared. Be careful of that. That tends to be where people trip up here, especially with how basic this structure is and how quick it is to plug in. That's a big stumbling block for a lot of students. So when I take whatever term is being squared, make sure you're distributing that exponent into that monomial. Okay, that's actually a technique we learned in section 2. So 3x quantity squared actually gives me 9x squared. Then I'm going to subtract. That's why it's called a difference of squares. And whatever my second term is, in this case, it's just y. So just y squared is simple enough. That's just y squared. Answer and done. Okay. All right, I'm going to go ahead and stop recording now.